Hey everyone, in this video we're going to learn how to perform operations with radicals, more specifically square roots. So in order to add or subtract radicals, we combine terms with the same radicands by combining their coefficients. Essentially, we're looking to combine like terms. Now when we were adding polynomials together, we were looking for terms with x squared to be combined, or terms with x. In this case, we're going to be looking for terms with the square root of 2 or the square root of 3 in order to combine all of our like terms. Now something to watch out for is we want to be sure to check that all terms are in simplest radical form first, because we may have a problem like the square root of 2 plus the square root of 8, which seems on the surface that we don't have like terms, but if we simplify the square root of 8, we would get 2 times the square root of 2, and then the square root of 2 plus 2 times the square root of 2 indicates that we do have like terms. Okay, so something to watch out for. Now, how do we combine those like terms? Well, we take the two expressions, we add their coefficients, and the square root expression stays the same. So again, just like polynomials, when we added terms with x squareds, the x squared didn't change. The same thing is going to be true here. When we add two expressions with the square root of 2, it stays the square root of 2. So let's look at our first example. 6 times the square root of 3 plus 2 times the square root of 3. So we do have like terms. They both are the square root of 3. So we go to add their coefficients, so 6 plus 2 is 8 times the square root of 3. And now we've added two square root terms together. Now in our next example, we have the square root of 20 minus 8 times the square root of 5. Looking at it, it does not seem like we have like terms, but the square root of 20 can be simplified further. We'll do it off to the side. The square root of 20 can be expressed as the square root of 4 times the square root of 5. The square root of 4 is 2 times the square root of 5. So this problem becomes 2 times the square root of 5 minus 8 times the square root of 5. Now we do have like terms, so we combine their coefficients. So 2 minus 8 gives us negative 6 times the square root of 5. And there we have both an addition and a subtraction problem to look at. Our next example, now we have three terms. So 7 times the square root of 2 plus 5 times the square root of 6 minus 2 times the square root of 72. So first thing we need to do is we need to simplify the square root of 72. Again, we'll do that off to the side here. So the square root of 72 can be expressed as the square root of 36 times the square root of 2. So that becomes 6 times the square root of 2. So rewriting this expression, we have 7 times the square root of 2 plus 5 times the square root of 6 minus 2 times 6 times the square root of 2. One more step to simplify before we look for like terms. 2 times 6 times the square root of 2 becomes minus 12 times the square root of 2. Now looking, we have two like terms. So we combine their coefficients. So 7 minus 12 gives us negative 5 times the square root of 2, and then 5 times the square root of 6 has no other like terms to combine with, so it stays plus 5 times the square root of 6. And if we wanted to, we can write this as 5 times the square root of 6 minus 5 times the square root of 2. Okay, they're equivalent expressions, so they would both be correct. How do we multiply expressions with radicals? So in order to multiply radicals, we multiply the coefficients together, and we multiply the radicands together. So in this operation, okay, both the coefficients and the radicands are being combined. And we want to make sure that our final product is in simplest radical form. So we may have some work to do after we take the product. Okay, so we can see here, a times the square root of x times b times the square root of y equals a times b, the product of the coefficients, times the square root of x times y, the product of the radicands. So simplify the following expressions. So 2 times the square root of 7 times negative 4 times the square root of 3. Multiplying the coefficients, we have negative 8. Let's fix that so it looks a little bit nicer. Negative 8. And then times the square root of 7 times 3 is 21. Now we have to check that our radicand cannot be simplified any further. So running through the factor pairs of 21, we'd have 1 and 21, 3 and 7. 1 is a perfect square, but that factor pair doesn't help us simplify any further, and 3 and 7, neither of those factors are perfect squares, so this is simplest radical form. Our next example, we have 5 times the square root of 6 times 3 times the square root of 2. So we'll start by multiplying the coefficients. 5 times 3 gives us 15. Square root of 6 times the square root of 2 is the square root of 12. Now the square root of 12 can be simplified, so we can write this as 15, and we're going to express the square root of 12 as the square root of 4 times the square root of 3. So we have 15 times 2 times the square root of 3, which is going to give us 30 times the square root of 3. And we multiply these two values together. And if you want, you can think of this as being in parentheses, right? And then we multiply the 15 and the 2 together. The square root of 3 stays the same. The last example here, we have this 2 times the square root of 5, quantity squared. So the first thing I would do is rewrite this as 2 times the square root of 5 times 2 times the square root of 5, right? Exponents are nothing more than repeated multiplication. We multiply the coefficients together. 2 times 2 is 4, and then times the square root of 25. Square root of 25, or 25, is a perfect square, so the square root of 25 is 5, so we'd have 4 times 5, which is equal to 20. So this expression, 2 times the square root of 5, when we square it, the radical goes away. And that's fine, right? We did everything as we should, and our final answer was 20. Next up, dividing radicals. So in order to divide radicals, we divide the coefficients and we divide the radicands. And as always, we want to make sure that our answer is in simplest radical form. So we can see in our first example, we have a times the square root of x over b times the square root of y, and that becomes the ratio of a over b times the square root of the ratio x over y. So first up, we have 3 times the square root of 14 over 15 times the square root of 7. So we're going to simplify the coefficients. Okay, so they both share a factor of 3. So that would become 1, that would become 5. And then, so we have 1/5. Then we're going to take the ratio of what's inside the radicands. So 14 divided by 7 is 2. And we can rewrite this as the square root of 2 over 5 to make it a cleaner expression. The next example, we have 12 times the square root of 8 over 4 times the square root of 2. So taking the ratio of the coefficients, 12 divided by 4 is 3. And then square root of 8 over the square root of 2, we divide the radicands. So that's going to become the square root of 4. So this is going to become 3 times 2, because 4 is a perfect square, which is equal to 6. Now something to notice, okay, square root of 8, some of us may be tempted to put this in simplest radical form first. That's okay. We would still get the same answer. Okay, it's just a matter of which operation you want to perform first. Do you want to do the division, or do you want to do the simplification? In the last example, we have 21 times the square root of 10 over 14 times the square root of 20. So taking the ratio of the two coefficients, they both have a common factor of 7. So this becomes 3, this becomes 2. So we have 3 over 2. And then square root of 10 divided by the square root of 20. The ratio of the radicands is going to give us the square root of 1/2. Now, what we should notice, if we have a ratio, we can express it as two square roots, one in the numerator, one in the denominator. So this is equivalent to 3 over 2 times the square root of 1 over the square root of 2. Square root of 1 is a perfect square, so we have 3 over 2 times the square root of 2. Now this is a little bit of an issue, because if you think back to the last video, we said a square root is in simplest radical form if the radicand has no factors that are perfect squares larger than 1, there's no square roots in the denominator, and there's no fractions inside the square root. Well, this is a perfect example where we have a square root in the denominator. So how can we simplify an expression where we have a square root in the denominator? And that's going to require us to do something called rationalizing the denominator. Okay, so for a fraction to be in simplest radical form, we do not want radicals in the denominator. Okay, so this is just a good reminder. So how do we rationalize the denominator? So what we're going to do is we're going to multiply the numerator and the denominator by the radical that's in the denominator. Okay, so what that's going to look like. The square root of 2 is in the denominator, so we're going to multiply the numerator by the square root of 2 and the denominator by the square root of 2. Now the reason this works, right, because seemingly we're changing the value of this expression. But mathematically that's not something we're allowed to do. But it's okay, because if we think about what anything divided by itself, this is really just equal to 1. Right, so we're multiplying this expression by the number 1. We're just doing it in a really creative way that's going to help us put the expression in simplest radical form. So now we perform our multiplication, so we go across. So we have 3 times the square root of 2 over, so now we have multiplication of 2 terms with square roots. So we multiply their coefficients, so 2 times 1 is 2. Square root of 2 times the square root of 2, we multiply their radicands. We get the square root of 4. So we have 3 times the square root of 2 over 2 times 2, which is 3 times the square root of 2 over 4. And now, these two values here and here are exactly the same, but this expression is in simplest radical form. Okay, so that's the process of rationalizing the denominator. Again, the key is multiplying the expression by the number 1, but just in a really, really creative way. So the first expression, negative 5 over the square root of 18. So we're going to multiply the numerator and the denominator by the square root of 18. So that's going to give us negative 5 times the square root of 18 over the square root of, I'm just going to write 18 squared here, and you'll see why in a second. Now, this is going to give us negative 5 times the square root of 18 over, well, 18 squared is a perfect square, right? I wrote it as a perfect square. So what's the square root of a perfect square? It's the number multiplied by itself to give us the radicand. So that's just going to be 18. Okay, so we actually didn't have to do all that multiplication out. Square root of 18 times square root of 18 is just 18. So a nice little shortcut to know. Now we have to check the square root of 18. It is not in simplest radical form. Okay, so just doing a little bit of side work, the square root of 18 can be expressed as the product of the square root of 9 times the square root of 2. So square root of 9 is 3 times the square root of 2. So putting that into our expression, we have negative 5 times 3 over 2 over 18. So that's going to be negative 15 square root of 2 over 18. And now we have to simplify the ratio of the coefficients. So they both share a factor of 3. So that's going to be 5, and that's going to be 6. So fully simplified, we have negative 5 times the square root of 2 over 6. So this problem's nice because a lot was happening, right? We first rationalized the denominator. Hey, we got to look at if we have square root of 18 times square root of 18, right? We multiply the radicand, square root of 18 squared, which is just 18. And then we had to simplify the radical, and then we had to simplify the coefficients. Okay, so it did take a few steps. Our last example, the square root of 2 over 5. So the first thing we're going to want to do here is we're going to want to rewrite this as the square root of 2 over the square root of 5. Okay, so that's a helpful equivalency to know, right? If we have the square root of a fraction, that's equivalent to the square root of the numerator over the square root of the denominator. Now to rationalize, we're going to multiply the numerator and the denominator by the square root of 5. So multiplying the coefficients, 1 times 1, we get 1. And then square root of 2 times the square root of 5, multiplying the radicands, we get the square root of 10 over the square root of 25. So that's going to be the square root of 10 over 5. Okay, so in this video we looked at adding and subtracting terms with radicals or square roots, multiplying and dividing, and we finished up with rationalizing the denominator. So now we know how to perform all of our operations with square root terms. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.